Hi everyone, I am Christiana Babe Damo, and today's video I am going to tackle about Euler's theorem. Leonhard Euler, a Swiss mathematician. In 736, he published a proof of Fermat's little theorem stated by Fermat without proof, which is the restriction of Euler's theorem to the case where n is a prime number. Euler's totient function. If n is a positive integer, then the pi of n is defined to be the number of positive integers not exceeding to n that are relatively prime to n. There are methods in solving the pi of a function. Rule number 1. If p is a prime number, then the pi of p is equal to p minus 1, since all numbers less than p is a relatively prime. Let's have an example. Solve for the pi of 41. Since 41 is a prime number and has two divisors, 1 and 41 itself, we use the formula the pi of p is equal to p minus 1, so 41 minus 1 is equal to 40. Therefore, the pi of 41 is 40. Rule number 2. If a is equal to p raised to n is a prime power, then the pi of p raised to n is equal to p raised to n minus p raised to n minus 1, where p is a prime number and n is an integer. Example, solve for the pi of 49. Since the pi of 49 can be written as the pi of 7 raised to 2, we use the formula the pi of p raised to n is equal to p raised to n minus p raised to n minus 1. So, the pi of 49 is equal to 7 raised to 2 minus 7 raised to 2 minus 1 is equal to 49 minus 7. Therefore, pi of 49 is equal to 42. Rule number 3. If m and n are co-prime and has the greatest common denominator of 1, then the pi of m times n is equal to the pi of m times the pi of n. Rule number 3 example is to solve for the pi of 55. Since the pi of 55 can be written as pi of 11 times 5, which is the product of two prime numbers, we use the formula pi of m times n is equal to pi of m times pi of n. So the pi of 55 is equal to the pi of 11 times pi of 5. Since 11 and 5 is prime number, rule number 1 can be applied, which is the pi of p is equal to p minus 1. Therefore, 11 minus 1 times 5 minus 1 is equal to 40. Rule number 4. If the prime factorization of n is given by n is equal to p sub 1, p sub 2, and continues until to p sub k, then the pi of n is equal to n times 1 minus 1 over p sub 1 times 1 minus 1 over p sub 2, and the product continues until 1 minus 1 over p sub k. Example, solve for the pi of 600. Since the only prime factor of 600 are 2, 3, and 5, we use the formula the pi of n is equal to n times 1 minus over p sub 1 times 1 minus 1 over p sub 2, and the product continues until 1 minus 1 over p sub k. Then we substitute the prime factors of 600 in the formula and the answer is 160. Therefore, the pi of 600 is 160. Euler theorem. Let n be a positive integer and let a be an integer that is relatively prime to n. Then a raised to pi of n is congruent to 1 mod n, where pi of n is the Euler totient function, which counts the number of positive integers less than or equal to n which are relatively prime to n. Example 1. Show by calculation that Euler's theorem is true for n is equal to 10 for all a is less than to n. Solution. All number less than 10 are 1, 2, 3, 4, 5, 6, 7, and 9, but only 1, 3, 7, and 9 are relatively prime to 10. Thus, the pi of 10 is equal to 4. Now, if we take any number, a is equal to 1, 3, 7, or 9, raised to the power of 4, then it is equivalent to 1 modulo 10. Now we have the 1 raised to 4 is equivalent to 1 modulo 10. And then 3 raised to 4 is equal to 81, which is equivalent to 1 mod 10. And 7 raised to 4 is equal to 2401, which is equivalent to 1 mod 10. And last is 9 raised to 4 is equal to 6561, which is equivalent to 1 mod 10. Example number 2. Show by calculation that Euler's theorem is true for a is equal to 5 and n is equal to 36. First, we need to solve for the pi of 36. Since 36 has two prime factors, which is 2 and 3, we will use the formula of pi of n is equal to n times 1 minus 1 over p sub 1 times 1 minus 1 over p sub 2. And the product continues until 1 minus 1 over p sub k. Then we substitute the values of a and n into the formula, thus give us the answer. Since 5 and 36 are relatively prime, therefore 5 raised to 12 is congruent to 1 mod 36. That's all. Thank you and God bless.